Today's lesson is Reflection and Line Symmetry, outcome SS 9.4. In previous grades, you learned about line symmetry. In this lesson, your knowledge of line symmetry will be extended. You will create shapes with line symmetry, and you will work with shapes on coordinate grids. How many lines of symmetry do you see in the photo of the Taj Mahal in India? Well, what a line of symmetry does is it's like a reflection. So if you were at the lake and you see the trees in the above ground, but you also see trees in the water. Here we see the Taj Mahal on surface, and we also see its reflection in the water. So we have one line of symmetry. Describe the line. Well, it goes here where the blue is. It's a horizontal line of symmetry at the water level. Where else have you seen lines of symmetry? Well, we see them in nature, on design logos, on Northwest Coast Aboriginal art, in architecture. So when one side looks identical to the other side, you see a line of symmetry. How can you construct a new shape when given a polygon by using a line of symmetry? A line of symmetry is also called a line of reflection. If a mirror is placed alongside one of the sides of the shape, the reflected image and the original shape together form one larger shape. The line of reflection is a line of symmetry of this larger shape. So if we start off with the original shape here, looks kind of like a couple of Z's put together, and we have a line of symmetry, we will recreate this corner down here and create the same shape, but only reflected across the line of symmetry, and the shape now is twice as big. So identify the lines of symmetry in these tessellations. So we have 3 columns of hexagons. Each column has a vertical line of symmetry. So if we take a look at just this column here, it has one line of symmetry through the middle. Okay, the second column also has a line of symmetry through the middle. The third one also has a line of symmetry through the middle. That means that if I folded this along this line, if I folded that section along that line, you would get the sides touching each other. This side would be an exact replica of the other side. Now, why is there only one line of symmetry in this whole tessellation? Because if I folded it here, this side has 2 shapes. It would have to go out to here to be a tessellation. Whoops, backwards. Okay, so the only line of symmetry here would be right in the middle. So if I folded this piece right directly in the middle, that this corner would touch this corner would touch this corner, etc. Now, what about this square? How many lines of symmetry does it have? Well, the square we could fold exactly in half, and we could fold it exactly in half the other way. But we also can fold it in a diagonal, and we could fold it in a diagonal that way. So a square actually has 4 lines of symmetry: horizontal, vertical, and 2 diagonal, or they're also called oblique. Oblique and diagonal mean the same thing. Okay, what about a rectangle? How many lines of symmetry does a rectangle have? Well, it'll have 1 vertically, 1 horizontally, but there will be no diagonal lines of symmetry in a rectangle. Okay, take a piece of paper, cut it in a rectangle, and try folding it. If you folded this across like this corner would be up above here. And so you would not, and this corner would be above here. So it doesn't fold exactly in half on a diagonal. It will horizontally, and it will diagonally. Okay, identify the triangles that are related to the red triangle by line of symmetry or line of reflection, and we're going to draw in those lines, okay, and describe them. So if we're starting with the red one, okay, we get B by horizontal line, and we have to describe where it is, through the y-axis, and it crosses the y-axis here at 3. So if you just use the words to describe it, somebody else could put that line on in the right position. Let's back up here and look at A. Well, the corner from here to here is 2 squares apart. So if we draw a line right down the middle, a vertical line, you will get A as the reflection. So A is a vertical line, and vertical lines cross the x-axis. Now this one goes through here at 5. Okay. Now, how did we get C? Well, C is actually not a reflection, because if I drew a line kind of even in between here, this bottom part of the triangle would be up here, and if I reflected it over that line, it would be upside down. So C is not a reflection. Okay, and the last one, D. Well, we can have a diagonal line of reflection, and in this case we do. So if we go from here, that's 1, 2, 3 squares across. So halfway in between, we will draw a line right here. So 1, 2, 3. So it's going to go at a diagonal like this. Now, we need to describe where that diagonal is. And it's actually, if I drew this a little straighter, it would actually go through 9 and 1, and it would go through 1 and 9. So let's jot down D. So D is a reflection on a diagonal line through points. 9, 1, and 1, 9. So be sure when you're saying where the diagonal line goes, you actually describe it by using 2 points. Okay, I want you to do practice 1. There's 2 handouts that you will need because you need to draw these. They will not be in your assignment booklet. So there's 2 practices, or 2 handouts for practice 1.